This one's going to be a little more complex. So we're going to do, we've got a car traveling down the road. And at time t is equal to 0, the car is going to travel, has an initial velocity of 20 meters per second. And it's going to travel down the road for a time is equal to 45 seconds at a constant velocity. At 45 seconds, the car is going to accelerate 1.3 meters per second squared so that it can pass another car. And it's going to travel 25 meters at that acceleration. Okay, it's going to travel 25 meters at that acceleration. It's going to be at a new velocity . And then it's going to travel at that new velocity for 15 minutes. And once it gets to this spot, it's going to take 250 meters to go from that new velocity to a velocity of 0. It's going to travel 250 meters for a velocity of 0. So I have 4 different parts to this problem. We want to know total distance traveled. We want to know the total time. I essentially have 4 different linear motions problems. I have 4 linear motion problems. I have, this one is item 1, this one is item 2, this one is item 3, this one is item 4. So I'm going to have to solve for different parts of this to get the total time and total distance. So for part 1, we know that time is equal, time initial is equal to 0. The time that's traveled is 45 seconds. We have an initial velocity of 20 meters per second. And we have an acceleration equal to 0. So I'm going to need the distance. Distance is going to equal my initial velocity times time. So I'm going to have my 20 meters per second times my 45 seconds. And now I have my distance traveled. And that's 900 meters. For part 2, I don't know time, but I'm going to need it. I know my acceleration, which is 1.3 meters per second squared. I know my change in position, which is 25 meters. And I need to know my new velocity. All right, I need to know my new velocity. So now I know my distance, so that's good. But I got to know this new velocity. Well, I can do v squared is equal to the initial squared plus 2 times my acceleration times my change in distance, which I know, this is all good. My initial velocity was the same velocity that I started with, so that's 20 meters per second. So this is gonna be 20 meters per second. My plus my 2 times my acceleration, which is 1.3, times my change in distance, which is 25 meters. So now I've got that. So I've got 2 times 1.3 times 25. This is 65. And this is meters squared, seconds squared. And I got 20, I gotta square it, and that's 400 meters squared, seconds squared. So I have 465 meters squared, seconds squared. My final velocity is gonna be 23.0 meters per second. Now that I have my velocity, I can solve for time. Velocity final minus velocity initial divided by my acceleration is going to equal time. So I'm going to have 23 meters per second minus 20 meters per second divided by my acceleration, which was 1.3 meters per second squared. That's going to equal my time. So I'm going to get 3 divided by 1.3. And this is going to be 2.3 seconds. So now I have time here and I've got distance for part 2. So let's look at part 3. So my new velocity for part 3, my new velocity was 23 meters per second. The time is equal to 15 minutes, but I need that in seconds, so I'm gonna have to convert. So this is actually 900 seconds. I need the distance because this again has no acceleration. So that's easy enough. That's just going to be my velocity times time. And I get my 23 meters per second times my 900 seconds. Then I'm going to end up at 20,700 meters. And then the last part of this is still at my new velocity. My new velocity is 23 meters per second. I have a change in position of 250 meters. I have a final velocity of 0. I don't know my acceleration. I don't know my time, and I don't know my distance. Well, I can figure out my acceleration because I've got v final squared is equal to v initial squared plus 2 times my acceleration times my change in distance. So I get v final squared minus v initial squared divided by 2 times my change in distance is going to equal acceleration. I get 0 minus 23 squared divided by 2 times 250 meters. And I end up with a negative 1.06 meters per second squared. And that negative tells me it's a deceleration. Because I'm stopping. So that negative is important. But now I want to find my time. V final is equal to V initial minus or plus my acceleration times time. So I get V final minus V initial divided by my acceleration. And I can calculate my time. So I get V final is 0, V initial is 23. My acceleration is a deceleration, so I have to carry that through, and that's meters divided by meters per second This meters per second, there we go, meters per second squared. And now I get the time that it took was 21.7 seconds. And now I can do my change in position. Well, we already knew what change in position is. I need this. No, we know what my change in position is. It's 250 meters. So we have that. So now we want to solve for the whole problem. So my time total is going to be the time from 1, the time from 2, the time from 3, the time from 4. Time from 1 was given in the problem, 45 seconds. The time from 3 was kind of given in the problem, but we had to convert it to seconds. We had to calculate it in part 2. And in part 2, it was 2.3 seconds. And we had to calculate it in part 4, which is 21.7 seconds. And now we're just going to add all of those together. So 45 plus 2.3 plus 900 plus 21.7 gave me 969 seconds. The total distance, I got to come up with it from 1 and 2 and 3 and 4. 1, we had to calculate it, and that was 900 meters. 2, we were given it, it was 25 meters. 3, we had to calculate it, and that was 20,700 meters. And 4, we were given it as 250 meters. So now I can total all of those up. And I've got 21,875 meters was the distance, total distance traveled. So now I can calculate an average speed, which is the distance total divided by the time total. And that is 21,875 meters divided by 969 seconds. And my average speed, and in this case, it would also be the average velocity because we didn't change direction any, is 22.6 meters per second. So that you can get that information all the way. So this one was kind of pulling everything together and bringing it all out as what started out to look like a very complex problem. We just had to break it up into its individual parts. Well, I have that. It's almost 8:15. So I'm going to stop my recording here. And I'll open it up for questions. And we will have lab today.